Let's see. Tom? All right. Welcome back. And welcome to the third of our team project presentations today. All of us are here because we want to do great things in space, big things in space. But doing great things in space also means that space returns great things to us, sometimes in the form of lots of data. And so our third team project examines this rather new phenomenon. So please welcome TP Space Big Data.
Thank you. Ladies and gentlemen, I'm sure you've been wondering for all our lives what in the universe this space big data is all about. Well, today is your lucky day because we are going to show you. But I cannot possibly hand over the stage before having mentioned how incredibly proud I am of the 32 bits people behind the stage, having had only less than 2 days to practice their data flow rates. So sit back, enjoy, and learn.
At the beginning, everything was black. And then there was light. And then there was data. And then there was confusion.
Hey guys, so it's been end of a long day, and there's just something on my mind. There's just so much data about space. Satellites, communication satellites, navigation satellites, high-resolution remote sensing. It's just mind-boggling. I can't really get my head around it, and I don't even know what to start calling all of this data.
You tell me, all that data, I'm so confused with that. And you know what? I think I got a BSH.
A BSH? What are you talking about?
Oh yeah, you know that it's a big space headache.
Big space headache, big space data, open space big data. It's not even about space. It's about the data. It's all about the data.
What about space data then?
Julia, you know better than that. Come on. It's not just space data. There's so much of it there. We have to figure something out, right? We have to figure out how to call this. It's huge. There's tons of it out there. It's everywhere. We have to be able to come up with a better way of dealing with this, right?
I don't understand that.
No needs better term. You keep on using the word big and huge. We need something special, something, I don't know, grandiose. No, brother. No. Come on.
I don't understand your point. It's like, what?
I have no idea either.
So
Please explain me.
there was still queues.
Stop.
And then there was the International Space University's Space Big Data team to make value out of it.
So we heard very interesting arguments about the definition of space big data. And as you saw, different people have different opinion. It is very hard to come up with something concrete, something solid that will accommodate all the different opinions we heard. This is why during our research we try to identify the main elements of space big data in order for us to be able to understand them and further explain them to you. You might have heard of the 5 V's of big data, and in the next couple of minutes we will try to explain you the 5 V's of space big data. And we're going to start with value, because data is all about the use we make out of it. Either scientific or commercial, value is a very important element of space big data, especially since a lot of people are not aware of the amount of knowledge that there is out there waiting for us to explore. I'm going to move to the next element, which is velocity. And my helpers here are going to show you what velocity is about. That was not fast enough. Not quite.
This is velocity.
Velocity is the second element. Terabytes of data are generated on orbit every day. High throughput satellites that generate all this data need quite some speed in order to be able to transfer them down to Earth. Velocity is the downlink, Velocity is the downlink that tries to transfer this data back to Earth. Velocity is the high speed actually of data flow. And at the moment, big data is being collected at rates much higher than the ones we can process. And we're going to move to the next element, which is veracity.
Data is truth? Yes. Quality. Authenticity.
Cybersecurity.
Veracity. In order for me to be able to explain to you today what veracity is, I had to open up the dictionary. And apparently it means validity, accuracy, and quality. And it is very important for the data users, either the scientists, business, or even individuals, to be able to derive meaningful information from it. Towards this end, we have to take into consideration that some data are irrelevant to our research, and that some data might be corrupted or totally inaccurate. And we're moving to the next element, which is volume. Can I? No, one. This is the volume of space big data. Volume is another word for quantity, and it refers to the amount of data that is being generated, stored, and analyzed every day. You might wonder, how big is space big data? We cannot provide you with an answer now, but probably by the end of this presentation, we will all know. And the final element, variety.
Vielfältigkeit.
Variety comes in so many languages and in so many different shapes and sizes. First, we have remote sensing data, we have Earth observation and images, we have positioning information, and this is only a very small amount of all the types of data that it's out there. It's very important for the data users to be able to handle all this data.
Wow, it seems so interesting. Can you tell me more about the space big data?
Of course. In fact, I know someone who can talk to us about data manufacturing.
So, space is full of fun to explore, and space big data is an enthralling activity, and the data manufacturers are the data collectors who collect data from space. The sensors, like instruments in satellites, then telescopes and observatories, collect lot of data in the form of raw data, that is ones and zeros, and all these data are in the order of terabytes to zettabytes. And what we will do with this data, all these ones and zeros, and what represents? It represents all the data from space and even from the ground surface, like the environmental conditions between the sun and earth. And even I have an experience to control some of the satellites having weather payloads. So can you tell what you will be doing with these ones and zeros?
Thank you, data manufacturers. That was a very interesting question.
So there's so much data generated. How can we store all the data?
Don't worry about it. We will hear from the data repositories on the ways we can store the data we produce.
Hello, I am the data repository, the central location that stores and manages data from space. Without me, there wouldn't be any data on Earth. I am so affable and so accessible to all data manufacturers, all data processors on Earth. I make sure I make data available to anyone that needs it. I am so very passionate about security and privacy of people. Therefore, there is some amount of restrictions with regards to data distribution from my repository. I make sure all the technology that I have is of best quality, and I use the most modern, the most excellent software infrastructure to store my data. My goal is to make sure that data is accessible to all persons on the globe. Without me, there wouldn't be any processors. Without me, there wouldn't be any data manufacturers. In fact, their job would be useless. I am the ultimate and the central figure of data manufacturing because I am the powerhouse of knowledge and research.
Thank you very much, data repositories.
But how can you make sense out of all this data?
We don't have to do anything. Data interpretation is done by data processors.
Thank you so much for all of this data, but it doesn't mean anything to me. I don't understand, and it doesn't mean anything to you either. Data is only as good as it can be turned into information. The biggest difference is data is just what you collect. Information is how you understand it. So, big data in general faces this huge problem of having all this big data. It's coming in quickly. It's coming in all types from different countries. It's protected. It's not protected. I'm too scared to use it because it might be protected. But we need to be able to understand it. The difference between being able to process data just a little bit and being able to really understand what it can mean and the information it can gain is tracking down and finding the Flint, Michigan lead poisoning problem. Finding that by using health records and information. We talk a lot about how we have Planet finding all of this information and manufacturing it, and that's great. And we talk about how we are paying them money in order to get this result and understand it. But what's the fun of understanding data if we already know what the results are going to be, right? We want to be able to actually use it. We've stored it all over the country, and it's nice to say it's in this cloud. So it's nice to think the cloud's right there and we can just grab from it and everything's in one place, but it's not. It's on pen drives, it's on paper, it's on your computer, it's everywhere. But it's not quite like that. I mean, you need to be able to access all of that, and that's through data processing. So, by being able to make sense of it through new technologies, we're seeing it now, just the beginning of the new age of data processing through techniques like machine learning, like AI, being able to say, you know what, I don't know what the results will be, but let's see what we can make of all this data we've already collected. And it's not just raw data and turning it into something that you can understand. It's also taking that processed information, saying, I found this a really reliable result and I want to combine it with this and get something new. Being able to do that represents the biggest difference between where we are now, in my mind, as the data processor, and where we will be in a couple of years when these have developed. Play me out.
Cool. Can there also be apps made out of all this data?
Of course, data can be everywhere, but it's not only about creating applications for cell phones. Data applications nowadays can help in many aspects of our daily lives. For instance, they can help serve farmers.
Hello, I'm a farmer. Oh, I'm great. Today I met a large space big data community discussing advanced technologies, advanced applications. Oh, great. Oh, can anybody help me to improve my crop production? Anybody?
Why not? Hey Naga, have you heard about the app based on the concept called precision agriculture? This is a novel technique which combines GPS data with the Earth observation data to provide accurate prediction for different features like crop yield, terrain features, topography, organic matter content, moisture levels, nitrogen levels. Also, there are apps available on the mobile phones.
Is it?
Yeah, which can provide you the information regarding the market rate for the crops.
Great.
So you can sell the crops in a more effective way. And also, then there is geographic information system, which can help you in employing sustainable agricultural practices.
Great,
So
great.
Big data is helping us in a big way. So 3 cheers to space big data.
Big data.
But who else can use this data?
Space big data can be used by absolutely everyone.
Everyone?
Everyone.
Hey, you're right. This is amazing. Governments can use space big data for disaster relief, city planning, near-Earth object planning, mitigation strategy.
Really?
Hey, also businesses can use space big data. Business intelligence, analytics, internet banking, energy exploration for oil, gas, and solar, cargo ship tracking, aircraft traffic control. Institutions and academics can also use it. Astronomy, weather, climate change, environment. Hey, you and me can also use it, normal people.
Really?
Citizen scientists, GPS users, smartphone users, precision farming. Hey, even when I access Netflix, US Netflix, I'm using space big data.
Oh.
Oh wow, that's not all. It will be needed in things in the near future. You know, this Internet of Things thing? You know, for autonomous cars? And perhaps the potential is never ending. It can be used for things we never thought of. It's so exciting.
Isn't it? Great. So at first we heard about the values of space big data, and now we have heard about from the representatives of the value chain of space big data. First the manufacturers, the repositories, the data processors, the data applications, and the data end users.
Wow, I'm so excited for space big data. I'm going to go and use it right now.
Yes.
And so, the data life cycle changes were born. It's just like finding a needle in a haystack.
Are we gonna go? Let's go. Time to start searching.
Oh, I found a challenge. So I'm an astrophysicist by training. And what does an astrophysicist do in their daily lives? Well, we are not looking at crystal balls to predict people's fate. We are also not building rockets. What we do all day long is digging through the big data. So, for example, during my master thesis, I was analyzing light curves. What is a light curve? Well, when we receive a light from a star, it has a certain intensity. And if you plot that against time, you get your light curve. But why is it a curve? Well, if that star also hosts a planet, an exoplanet, and that planet goes in front of the star, the light gets dimmed, so the intensity drops down, and so you have your curve. I wanted to analyze special features of light curves, and so I needed to get my light curves. I was looking at a lot of data repositories. For example, the Exoplanet NASA archive and Corot, that's the one from the French agency, but there were also a lot more. So my first challenge was to find all the data repositories that could provide me with light curves. The second challenge was the access, because to some I had to subscribe, some I could get free. And for example, I even had to write an email to NASA because they had a bug on their website, so I couldn't immediately download my light curves. But the biggest of all challenges was due to the lack of standardization. Because even though all this data from these different repositories should contain the same data, namely the data points of the light curves, they were all stored in different ways, like different data formats, in different columns, even different decimal points, different delimiters. So I had a hard life writing different programs for every single different archive to analyze my data. Thank you.
Oh, I got one.
Hi. The challenge I just found is about openness versus privacy. Openness is easy to understand. Data is a special kind of resource, which is different from natural resources like oil. You give your oil to somebody else, you lose it. But you give your data out, you don't have to lose it. You can still keep it. So, the more people big data is shared with, the more value it may generate. But the problem is, when you share your data, you kind of lose control of it. That's where privacy issues start. I suppose many of you guys may know about the great novel 1984. You know, in the world of 1984, Big Brother is watching you. Everyone lives in fear. Well, in the world of big data is Big Brother. Wherever you go, whatever you do, big data is watching you. High-resolution satellites are scanning your house, your car, and someday even yourself. GPS, GNUNAS, and Beidou are tracking your location. Google Street View cars are taking pictures of your face. It's like you are totally naked in front of the whole world. So, when big data is watching you, when people who control big data may know everything about you, are you scared? You should be. Thank you. Without privacy protection, each of us may become a victim. Many people may live in fear. But don't worry so much. There are solutions. We'll talk about the solution stuff later. Thank you.
Oh, what did you find there?
Okay, I've got a challenge. Hello, YouTube. This is Voice from Mars. You see, I am a tourist astronaut, but I prefer you guys call me Mr. Millionaire, because I paid NASA 1 million shekels sending me to Mars. And this is the 10th day since I come to this amazing planet. Okay, it's time to collect my medical data. Before start, I want to show you guys some cool stuff. You see, it's the artificial gravity lab. It simulates the gravity environment of Earth, where I can walk upright, I can have a good sleep, and I can eat kind of foods without worrying about choking. And every day I come here to let the ground station to collect data about my health condition. You see, there are many sensors beneath my spacesuit that will record my heart rate, blood pressure, and metabolic index. This data will analyze through life support system to make sure if I'm feeling well, and assess the human performance in space, and also be used into scientific use. So actually, I'm a science experiment as well as a tourist. The more data they collect, the more accurate the result is. But my concern is that how this data be protected. I could not imagine how bad it would be if this data were exposed to the public accidentally or sold to someone else. And this will cause more tension in the future because everyone knows many other space tourists will have the same sensitive data collected, and everyone will be accessible to outer space.
I found one more challenge. So I'm a researcher and I do rockets, I do rocket science, I do propulsion research, and I really want to make rockets safe. So I really would like to compare the experimental results with results of other research groups, which are actually many all around the world. But the difficulty comes when comparing the results because different groups use different model assumptions. The data can be incomplete. Even when it's published, there are time delays between data acquisition and publishing, which all leads to uncertainties and which all leads to a situation when the data cannot be really trustworthy. And this is also an issue in space big data.
Found one more challenge. Big data is not about the data. It's about the value you extract from it. We need to remember that we've heard already from manufacturers that there is a lack of standardization. This lack of standardization carries over to the processors. Because if the raw data collected from Mars, from people on the space stations, the commercial space stations in the future, and the satellites orbiting our planets and other planets, then we need to be able to do something with it. We need to create meaningful information out of that. We have a number of challenges when it comes to that. We have, for example, the problem that typically there's a 10-minute download link between the satellite and the ground station antenna as it passes over. This is something we need to take into consideration because, for example, the Copernicus system alone generates a volume of 3,000 terabytes, around 3,000 terabytes a year. That is per day a velocity of several terabytes. So that's a lot of information. That information is stored aboard but cannot be always downloaded at the same time.
Thank you very much. As I was hearing you, I was keeping my scientist notes, and I would like to invite you in a discussion before you leave the stage. You're facing a lot of challenges, and probably way more than the ones you have mentioned. It seems that some of these challenges are actually overlapping. And indeed, data players are interdependent and they interact a lot with each other, so sometimes they do encounter similar challenges. We have heard so far about the lack of standardization, the issue of privacy, especially when it comes to open data, how space big data can even affect human performance in outer space, how important it is to have trustworthy data and being able to combine them all together to come up with the result that you need, and the manufacturing, engineering, and commercial challenges that big data result in. Maybe we can try to crystallize these challenges into the 4 core ones. What do you think? Should we keep discussing? So these are the 4 big challenges that space big data are facing at the moment. And we are ready to move on.
And finally, there was a message for everyone who represents humanity and beyond.
Hello everyone. Welcome to this distinguished lecture. We want to thank our host, Kanika, John Connolly, the outgoing director of ISU, the chairs, and all support staff. Actually, we thank our whole ISU Space family, with whom we spent all our sleepless nights during the past 2 months. Lastly, we also would like to thank our families for their support. These are the last official moments of ISSP16, and we are honored to host this ISSP16 panel. If we discuss big data in 10 years ago, it will be too early. If we discuss it in 10 years, it will be too late. So now is the time. So listen and take away your message. So just for you, we invite four distinguished guests who will personally address you. These space big data stakeholders: Robert Jacobson, representing end users; Henry K, representing government institutions; Karthikkumar as our smart scientist; and finally, Kanika Anand will be the commercial private sector. We kindly ask the audience to refrain from applauding and hold your burning questions till the end. First, Robert Jacobson, our authority of end users, will share some recommendations how to live a better life in peace with your data.
Thank you, Mr. Moderator. So to summarize again, end users are really all of us, taxpayers, citizens of the world, whether you're a surfer or a space cadet or a cyber surfer, we're all using big data in a lot of ways. Wait a second. They told us to turn off the phone. It's buzzing it. You know, I downloaded this app you've probably heard called SETI at Home. There's some great... Oh, okay, SETI at Home. Basically, we're looking, you can use space big data to help look for extraterrestrial life. I got a positive message. Do I swipe right? But just making sure you're paying attention. But there's some amazing applications that citizen scientists can use, like SETI at Home that's been out for a while. There's also Task Force, which is basically a group that allows you to use data for mapping during disasters. And you know, if you're using GPS or Google or a bunch of other opportunities to track gravity and weather, big data applies to you. It's useful in all of your life. So we need to support space big data because it enables us and industry and agencies and governments to continue to create applications that will be useful for all of us.
Okay, thank you, Robert. So if your bread and butter depends on the government, please pay your precious attention to our 100K from the Ministry of ISU Space Big Data.
I'm the minister. I just woke up and I didn't have my morning coffee yet. I'm the most important person in this panel. So, and I have news for you all. You might not know this, but there is this American company called Google that publishes these high-resolution imagery of your backyards online. And I don't know, maybe it's new information for you, but I got a lot of messages from my beloved voters this morning who were telling me that they have really, they're feeling anxious about their privacy being violated. So, and I have to do something about it because these guys are voting for me. So I shut down and I restrict the access to the big data that I produce. But now all the businesses and all the scientists come to me because they want to have open access to the data that we produce. So what should I do? I need to find some sort of balance and between the openness and the privacy. But now the problem is that space is like, it's like an international place. Like you cannot just restrict it to one nation. So nobody tells me that when I find the balance in my country between openness and privacy, that all the others would agree. And since the internet connects everybody, we need to find an international agreement between openness and privacy to gain the most value out of it. And that's the only way we can move forward.
Okay, thank you and good morning, Mr. Minister. Now, if you belong to those special individuals who dedicate their time doing research, please listen carefully to our scientist, Karthikkumar.
Thank you, Mr. Moderator. So listen, whatever's been said here, there's only one thing that matters. Data is science, and science is data. There's no other way around it. In fact, astronomers have been at the forefront of space big data before any of us even knew what those three words meant. Take, for instance, 100 years ago, Hertzsprung studied tens and thousands of stars and derived the famous HR diagram, which still to this day forms the backbone of our understanding of how stars form and evolve. And astronomy isn't standing still. In fact, there are facilities coming online in the next few years that are going to completely transform our understanding of the universe. Take, for instance, the Square Kilometer Array, a huge array of radio telescopes. And essentially, what's going to come out of this, when it's at full capacity, is 700 terabytes of data a day. Let me let that sink for a second. 700 terabytes. But you're probably wondering, 700 terabytes, I mean, that's a few more hard disks, right? 700 terabytes in capacity is more than 3 billion iPhones every single day. And to stay on top of this, astronomers also have to be on top of all of the technology. So they're also leading the way forward with research in artificial intelligence, quantum computing, machine learning, and a host of other fascinating areas. But the research that is being done by scientists isn't just about galaxies and stars and things like that out there. We heard a little bit earlier about the fact that human performance in space is a huge factor and an area of research. And the more we understand about human physiology, the more we can plan for long sojourns on artificial gravity stations, or even sending people to Mars. And since we all want to do that, we have to be able to deal with the issues of data related to these missions. And so, in fact, scientists are also aware, as my esteemed colleague from the government mentioned, of the issues related to privacy. But the most important thing is unless scientists get this data, we won't be able to take the steps forward to make these missions successful. And the most interesting thing in all of this is when you think of a scientist, you might be thinking of this elite group of people who are sitting doing research. But as my friend Robert here mentioned, there's actually a way for all of us to get involved. And in fact, I encourage you all to sign up on citizen science platforms like Zooniverse or even download SETI at home. Because in every one of you, there is a space big data scientist. And the only way we can make the strides forward that we need to is if we work together, collaborate, and in that way solve the mysteries of the universe.
Okay, don't say no, just follow our scientist. Thank you, Mr. Scientist, for showing how to untangle your bits. Last, but not least, is our commercial sector. Show where the money lies. Kanika Anand, the stage is yours.
Are you sure?
Yeah.
Are you very sure?
Show me the money.
You show me the money.
Show me the money.
No, you have to show me the money first.
Okay, please show me the money to the public.
We money lovers, or I should better say the commercial sector, we need to show you guys the money. But how are we going to show you the money if you all don't show us your data? If the industry doesn't share what all the possibilities are, what else is being developed, what the future missions contain, and what else will be coming downstream here on Earth. We're the ones who basically make sure that applications reach the public. We make sure that governments can actually work with the data. They know what to do with disaster management. I mean, we're the ones who are actually doing the real stuff. I mean, for heck, we're the ones who are sending Mr. Million up to Mars. It's not the government who's doing that. So it's really important for us to know what all is happening. We need better communication between all the sectors within the SBD industry. We need to communicate way better. And how we're going to do that is often a million-dollar question in itself. But the commercial sector really needs to open source everything. We are forced to share everything for free. However, we also have to make money and bring it all back in again. So the future really lays in the new generation's hands. We need more data scientists, more data analytics, the ones who can actually work in our organizations and deliver more out of the data than other institutions are doing. We need more younger generation competing with space apps challenges and focusing on SBD. We need more people to actually realize what SBD is and how important and essential it is for us. Because we're the ones who will make it big, and we're the ones who will bring in the money. So we need more support of all of you. Thank you.
Okay, thank you, Kanika. Show where the money lies. This was only an extract of the solutions and recommendations we have discussed here at ISU. But I think we borrowed the audience attention for long enough. We like to avoid them drifting off to the Dream It, Launch It hangout. So, audience, please, let's thank our distinguished speakers to have dedicated their precious time to presenting their roadmap to us today.
The most valuable commodity I know of is information. Wouldn't you agree?
I agree, and you should all agree. Data is everywhere. Data is the source of all knowledge. Raw data form the basis of technological advancement and scientific development. Data that are stored and collected right now form the basis of our future. Space big data that are collected now are already there. In fact, we live at the turning point of the space big data sector. In the coming decade, everyone, science, governments, business, individuals will start using big data in a way that will transform our everyday life. This is the moment to get involved. They don't flow very fast, the data today. That's the data range.
right, thank you, Space Big Data. All right, so you guys tackled a very difficult subject, and did it in a way that made it entertaining. But it does still raise questions. So if I may be the first, every time I've seen you guys do this presentation a couple times now, and every time I learn more, and you know, every time you learn more, new questions come to mind. So watching the haystack, one of the questions that came to my mind was, are we generating more data in space than we're using? And if we are we violating some sort of economic rule of supply versus demand? Is our supply of data from space so much more than our demand of data from space?
So I think this is an excellent question, and one we grappled with over the last couple of weeks. Interestingly enough, I don't necessarily think, from what we've analyzed, that the problem is really supply and demand. It's the marketplace. So what you discover is a lot of people don't even realize how underutilized data actually is. Take, for instance, the European Commission's Copernicus platform. There's a lot of people who are using data there, but the utilization rate hovers in the 30–40% of data. But if you look at the kinds of ventures that are being embarked on right now, it's clear that there are needs for this kind of data, and there are disruptive applications out there. So what we've actually discovered as part of the challenges and the arena, the way it looks at the moment, is that more than there being a problem of oversupply or under demand, it's a question of both sides being able to find each other. And that comes from a process of education. And in fact, we spoke to someone at Northern Sky Research, and they're actually releasing next week their very first report on space big data. So our timing is perfect in this sense. And what they identified to us is, in fact, that one of the biggest costs is raising customer awareness in this industry. So making it clear that there is this kind of data out there, that you can do things with it, and structuring that in a way in which the market can drive it is still an open puzzle. And some of the recommendations we have in the report go towards that. But finally, putting all of that together will take an effort of the entire community. Anybody else want to add to that?
Okay. The answer to John's question, I think, in some sense, is true. There are too much data than people demand. But I think that's the reason why big data, space big data, exists. And I want to give you an example. I think it's about 1970 or sometime, that when the computer is not so popular, and you know the story. Okay, IBM or something. The boss think that the people will not need a computer or a family. Why a family want a computer? What is it for? But now every family need a computer. I think the answer is now maybe more. Maybe there are more data than people require. But after space big data developed to some level, then actually the data is not enough. Thank you.
I think data is OER, but the data is more than OER. Now, that doesn't mean the telescope or the satellites produce more than data we want. Data, when OER give you use it, then it disappears. When the value behind data, we can't use out of it. When you use it, and have research, deepen research, you will find more and more value from it. So we see now we have not take the most use of the data. It means we have not taken all of the value from data. Thank you.
Well, I think John's question may depends on the users. As a commercial use, maybe from John's point of view, they think that the data is too much for them. But For scientists, sometimes they just need to store all the data for like 100 years, 200 years, all the data, because you don't know what's in that data. Maybe you just store it, and maybe 50 years, 100 years from now on, actually, this is what happened, because when we look at the data 50 years ago, we found some new astronaut, some new stars. So I think John's point of view may be from the commercial use, actually.
Thanks.
Big data.
Yeah.
A lot of information, right?
Yes.
This is a big data answer, by the way.
Yes, actually, yes. Yes. I was going to mention the need for pre-processing and processing on board. There is one thing, and that is that when we spoke to Philippe Armbruster, he did mention a bit of a supply push on the side of Copernicus, but the need to actually get to process that data on board. So if you have artificial intelligence on board that can distill those important data that you need, then you won't get all of it down. And if you're not able to download it, even through the EDRS system that we heard about earlier, then you'll be able to get the most important data, because that data will be collected, but the AI will be able to distill the importance out of that.
And you just answered part of my question, was how do we keep the analytical capability up, and is AI an opportunity there, which it sounds like you guys looked at. Doesn't replace judgment, so how do we ensure timely judgment and ability to communicate doesn't get swamped with big data, even with smart analytics?
So one of the things is the whole big data movement came out from another industry. So we know there's the likes of Facebook and Google who invested a lot of money in trying to understand how to build an ecosystem of tools, but also people, to be able to deal with big data. And the funny thing is that the words big and data are very common words in the English language, so everybody thinks they know what big data is. But when you get to the crux of it, you realize that there's some key features that really matter when you're talking about big data as opposed to regular data. And that line is not a strict line. So what happened in at least the internet industry, which we perceive will happen in this industry as well, is you have specialists who are trained specifically to be able to look at this trifecta of science or statistics, programming, and business, to be able to do the kinds of assessment that you're talking about. And this is the entire field of data science, actually. Data scientists are very sparse. There were a report by McKinsey that showed that by the end of the decade, there's going to be a shortfall of over 100,000 data scientists in the US alone. So there is a matter of investing in technology, but also in people. And you're right that judgment is required along the path, especially because AI isn't foreseen in the next few years to take over all of that. Even as it does encroach on our computing capacity and our ability to make decisions, there's still a human element that belongs to that. And so we'll have to do the same thing that the internet industry is doing, which is attract the brightest minds who have these skills and give them the right salaries, the right jobs, to make sure that they're motivated to do the same things that they're doing for Facebook, Google, LinkedIn, and various other companies.
Yeah, I think for the artificial intelligence part also, we need the users. So we need more like a survey of all type of applications which people need. And then only we can train the AI or the neural network part. So we need more of the users. Users should be aware of what they can get from the big data. So there should be more of maybe some classrooms or some special, in my place, there are some area of opportunities programs. So they are basically to tell about that, how users or how farmers or how the scientific community can use the data. And they can give their feedback that what type of intelligence they want to extract from that data, and then only AI can be trained. So that is the human factor I think Karthik is saying about. So that's that.
I think I can add some more technical details we found. It's the internet big data has used artificial intelligence and lots of big data mining, but somehow they use the metadata or they process the text information. But the difference is that most of the space big data is in the form of images and digitalized signals or something like that. You don't have lots of text or from the aliens or something like that. So that's why space big big data is very difficult to do data mining to extract information from the data. But internet big data, they're doing lots of, they're making lots of money from it. So we need to talk to our customers, and then we decide what kind of AI technology we can do to process that problem. And that's kind of the difference. Yeah.
I'm just going to mention one quick thing still, and that is that we heard about all these different challenges, and we also know that we're roughly standing at that challenge barrier, and we're trying to jump that barrier. Some are leading the way in this, for example, Orbital Insights. We need to get the whole industry, so the stakeholders, to come together and to actually jump that barrier together. Because as we heard, there are technological issues that need to be discussed. There are some legal issues that we need to consider. All of these players need to work together to be able to continue to extract the information, the meaningful information, the value, and to grow this industry.
Thank you. I just had a small question. I just wanted to hear your perspectives on how would advances in quantum computing will affect the big data in radical ways.
Well, I can make maybe a mention of, so there's this company called D-Wave, for instance, which has a close cooperation with NASA Ames. So there is already at the foundational level now a lot of interest in what quantum computing can generate. Quantum computing also poses a problem because in potential, it means that potentially all encryption methods we have at the moment can be broken in polynomial time. So within the time on a normal computer, you'd be able to break every single code out there. So given that the space industry has a strong military and defense aspect to it, quantum computing on the one side is a threat in the sense that they have to be able to leverage that to be able to protect their assets and information. But on the other side, the flip side of it is that it will ensure that what's happening basically with Moore's law now, that you'll have a quantum leap basically in computational ability, which means that, for instance, things like AI on board, they're not straightforward. We had a visitor here from Ramon Chips talking about FPGAs and these really complicated circuit boards. And quantum computing is the next step in that that'll allow us to do things like AI on board or autonomous operations or decision-making without humans in the loop necessarily. So quantum computing itself, I think, is not the holy grail, but it is just another stepping stone in the technology stack that can afford us the ability to achieve some of the goals that we're looking at, whether it's on board or even offline, to be able to do the kind of processing that we're talking about here.
Some notes about quantum computing. Maybe everybody knows that quantum computing right now is can be used to analyze primes, right? So analyze primes. But actually, quantum computing is a couple of AI, especially the deep learning technology. So the structure of the computers, they are very suitable to do that kind of computing. I guess I heard some of the information there. So if it is invented, it will be the perfect tool to do AI. That is the idea. Yeah.
Thank you. So first of all, thank you for shedding light into a very visual way into an issue which is often not understood. So thanks for that. So my question is, as an academic person, big data is something which I face every day, with coming from experiments in my laboratory and countless students working on stuff. So imagine me sitting in my office, crying, shouting out loud, where is my help? So as an academic person, so with limited resources and personnel and funding, not being able making that much money with the research to go for commercial partners, so where is my help to deal with big data?
So as an academic, the space big data helps a lot. Even there are many applications for tele-education. Such applications we'll be using, and so that the academic people sitting in many remote places, or all this will happen with the help of the space big data. And in commercial aspects also, it helps a lot, I think.
I think as an academic professor, I think there is a lot of changes in big data, space big data. As we know, big data is is a hot topic in our society. Everybody talks about big data, but I think big data from space is different from other big data, because space big data tell us the big problems of our land, ocean, atmosphere, and cosmic. So I think the most important thing in space big data is how to interpret, how to modeling our planet, about Earth. So I think there are a lot of things for academic professor. The commercial company and the government need your help. So don't worry about, you will get a fund from them.
So, Renee, this is like one of the main questions I've been struggling with throughout this whole project, and mostly it was basically coming back to the point that our institutions within the space sector has a big difficulty in getting the support from outside, as well as from the governments and from the manufacturers, or the ones who actually bring the space mission to its point of getting into space. So institutions really need money. That's the main issue. They need money, and they need scientists and younger analysts who are ready to dedicate their life to it. So what I would say is, it's really important that as governments are having their problems, and it's always very unpredictable with them, it's very important to have the commercial sector more and more involved with this. Sharing what you're doing, in some way giving them certain kind of patents, promising them dividends, that would help more investments coming in. That would actually create a bigger support for you in a longer term, not something when a government would say for the 2 years term or 3 years term. It would be something more for 10 years, like they would be investing for a long term. And you'd have more and more younger people coming in, or more and more specialized people coming in, because they're ready to invest for that. So I think that's like where you'll get your biggest help.
Okay, I think, well, at least partially you've answered my question, but if you can be more specific on that, is what is unique about space big data? I mean, what's the difference between space big data and data coming from an MRI machine daily, or an ultrasound machine everywhere in the world that can be assembled and analyzed? You mentioned that the main difference is the generation of images instead of text, but you know, bits are oblivious to how they're generated. So is there really something which is fundamentally different in space big data? This is one thing, and the other is related, and it's a question about the methodology. Are there any specific methods used for space big data that are not used elsewhere? I don't know, maybe compressed sensing or other analysis methods that are unique to this area.
So I'm not going to cover the technical pieces. I'll allow some of my colleagues to do that. But in terms of what is the fundamental difference, or one of, in my opinion, the first differences you see between space big data and other big data, is that if you go to an MRI machine and you receive all of these results, you say, that's my health. And if you're driving a car and you get into an accident, you say, that's my car, I could have been hurt. But when somebody takes a picture of space, it's difficult to tell the layperson, this affects you. Which kind of ties back into your question, Renee, which was, where's my hub? And I believe that your hub will come from the normalization of openness and the idea of, there is this data, let's use it effectively. So it's difficult to find applications of something that you cannot automatically see the commercial benefits from, or even all of the research benefits from it. So the biggest difference in why it's difficult for space big data to get traction is, you don't immediately see the commercial benefits, which drive so much of the other industries. So in my opinion, from the fundamental philosophy of why is big data different from, or space big data different from normal big data, that's the way I see it. And that's what I've seen from different applications of it across the board.
I can maybe just mention a couple of things. So your question was asking why it's different. I think you can rephrase it and say, why is it the same? Because part of the issue is that we think in the space industry that we're doing things that are very, very different when the bits that are in the computer are pretty much the same thing. So there is the technical aspect with things like sensor calibration and the metadata that goes with the data, and privacy issues and legal issues as well. Like, how do you easily distribute all this data when, you know, Facebook can just use the internet? Is there a legal norm for you to be able to distribute all of this data and for everyone to be able to extract value out of it? Those questions are all particularly relevant to space big data. But the interesting thing that came out of our conversation and when we were constructing our story is we realized in a lot of ways it's not different. And the real difference comes from this moment of realization, or this moment of understanding that there is all of this value in this data. And in fact, there's a very good reason it's happening right now. And the reason that all of these constellations are being planned and, you know, analysts are looking at this as an opportunity is because the world is kind of coming to that realization. And the same thing happened with the internet age. There were a series of technologies that resulted in growth of data, but there were a number of leading lights in that industry, and now you see a lot of followers. Big data has become a very normal term in the internet industry, and it's not normal yet in this industry. And in fact, if anything, that was our biggest challenge, and our mission statement includes definition of space big data, because we realized, in some sense, after us spending this many weeks here, even none of us really has a full sense of what space big data is yet. And that requires breaking down some barriers, breaking down some preconceptions about what space big data actually is. So in some sense, I mean, there's a technology aspect, legal aspect, ethics, various other aspects to it, but maybe the point is that we as a community have to just come to that realization that we're sitting on a gold mine, and it's not just the other industries that are generating big data that have that opportunity.
A lot of things to think about with this subject, and I appreciate the effort you put into it, and in the presentation, it was very absorbing. I have too many comments, so I'm only going to pick out a couple. One is that keeps coming back to me is, and this isn't really necessarily require any feedback, is I've been around the subject of the promise of artificial intelligence for many decades, and I just worry about AI truly being artificial ignorance rather than artificial intelligence, unless there's real human intelligence behind it, an understanding of all the complexities and all the, you know, the difference, the saying that one person's noise is another person's signal. You know, what somebody discards because it's in the raw data, because it's not what the AI system said is needed, turns out maybe there's the most critical information is what a system may discard because they weren't asking the right question. I had a personal experience on Friday in Tel Aviv when I was at an archaeological site, and I ran into a team from Germany that was actually doing some additional archaeology, and I got into discussing with them, and I said, did you know that there's a portal on the web that UNESCO helped to sponsor an ISU team project on how archaeologists could use space data to help guide them to interesting sites? They had no idea. And just an example. And then another one about, of course, the tie to the environmental challenge that our planet faces, that the subject of societal benefits that may go well beyond anybody putting a dollar sign on it as a commercial benefit is something I think we all need to reflect upon. It's important that all of you be ambassadors for the subject and to carry that forward. I will ask one question, and that is, did you examine or discuss the need for off-Earth repositories for key data? And one perhaps tongue-in-cheek silly example, I was imagining the Death Star from Star Wars turning into perhaps a data star, a facility or something, maybe on the moon, as we had a team project to look at a lunar archive, but some other way to have some redundancy for some of the most critical data that we must preserve or should preserve.
I can make a quick comment, and I think probably a few people have ideas here. I know, for instance, there was a Google project out of the research lab of putting a data center on the moon. So you have the South Pole Aitken Basin, where you have these permanently shadowed areas and the peaks of eternal light, which because of the geometry, they're basically always seeing the sun above the horizon. So there was this idea of basically putting cold storage. That means stuff that is in archive. So you don't need to access on your phone right now, but you can recover stuff off tapes out of cold storage. And so they did an assessment, and a cost assessment to see if they had solar panels on the eternal peaks generating basically limitless energy. And they had these servers basically in the shadowed regions, if they could reduce their costs in the long term. And what I understood from that is that from an overview perspective, it is a good idea. It's just it hasn't been fleshed out enough to understand what the costs are. And from my understanding, they didn't yet approach the space industry about this. So it was more a white paper and an investigation actually from people who are outside the space industry to some extent. So my anecdotal evidence is that yes, people are looking at things like that, putting it on the moon. That means you have, all the cooling issues and various other things that are solved. The one issue is, of course, the moon at almost 400,000 kilometers means that, transmitting data at the speed of light, there's latency. And that latency means that you can't use it for real-time analysis or various other things. So that's the reason why some of these constellations are flying lower and lower as well, is to reduce the latency so you can do, real-time gaming or whatever application that people want to use it for. So places like the moon would be interesting, but it also comes with a caveat of, what are the restrictions and what box do you put it in for future use. So from my anecdotal evidence, there is stuff like that about, but it just requires more research to be done.
Quick word, it's like every problem in big data, everybody has a different idea because he has a different need. And it might be useful for somebody, but maybe not for others, because they have real-time requirements, for instance. And maybe in that case, it won't be a good idea. But for other type of data, maybe it could be a good idea. Just it's really something which is a characteristic, in space big data, is there are so many type and different formats and different use of the data that there is no one solution for every problem. It's a combination of every solution.
I think the problem, the question is very interesting. From my personal point of view, it's about the data repository, just like it's about data repository. And if I would like to build something like that, I think I would store the DNA sequences of all the creatures. And it will be like the Noah ship, the final resort for Earth. So if we have an extinction, we can use that data on the moon, and we have the DNA sequences, we can replicate all the creatures.
About data repository, we have talked about in our team. And I think with the development of technology, we will solve this problem. And Google and some Chinese companies have developed a repository in the ocean, using the tide energy, turn the tide energy to electricity, and using the water, deep water, and the environment to cool for the cooling of the system. So I think the technologies will solve the data storage. Where I think the most important thing for data repository is interoperation, because many countries are setting up their own repository where many data was repeated stored. So I think the most important thing to how to combine this separate repository together to make data sharing a good infrastructure for data sharing. The broker and the user maybe they don't want to know how to visit, how to use the data of the repository. I think there should be some protocol for the user. They can use it very easily, and don't require them to know the details of your repository. I think this is the most important in the operation. Thank you.
One last question.
I want to refer to the challenge of making information out of the data and applied to autonomous satellites. And do you have any recommendations or examples of using this, but based on the current state of the art of the computers, not on future? And the second question is about the problem of hacking. Do you expect any hackers trying to tamper with big space data?
So, if I can rephrase your first question, and then maybe I'm the right person, maybe I'm the wrong person to answer it.
Okay.
What I understood you were saying is with more autonomy on board of spacecraft, how with current technologies and current limitations, we might still be able to grow basically the data volume, velocities, and things like that. Was that your question?
No, actually it's I'm talking about the algorithmic issue, because there is no point with having big data without using and converting it into information. And the first application that I have in mind is using this to increase the autonomous level of spacecraft.
So fortunately, we have someone here. I think you have, who's worked on clean space initiatives. You can maybe speak about autonomy.
Yeah, you're right. I mean, if you look at the state of the art of satellites, like the computing power that is currently available is quite limited. So the amount of artificial intelligence that we are speaking about that you can really apply is also very limited. Like, they just start nowadays to use image processing to identify, for example, for autonomous docking, the surfaces and so on. So what we are talking about is already much more advanced. But what is very important, though, is that in the technology that we develop at the moment, we take into account that we can change, and like whatever we upload to the satellite is not like 10 years old or 5 years old, because that was the time when the algorithm was developed. So we need to make sure that we can reprogram the satellite in a way that we can use the end user's perspective. For instance, if current state-of-the-art research comes up with a new solution, that we can upload that to the satellite, and therefore we gain more of the data. But at the moment, like, people investigating FPGAs and like increased computing power on a satellite, but at the moment this is still at the very beginning, so it needs to be increased. Yeah. And for your second question, addressed the hacking?
Yes.
Well, we haven't investigated that.
I can tell a few words on that because, well, I know it's something about cybersecurity. Actually, it is almost the same problem as for all data repositories. Cybersecurity, it's just a matter of how you manage the data, how you download it, how you provide it. And there's already a lot of studies that have been made. Internet has the same problem about cybersecurity. So you just have to comply to all the standards that exist. And normally, you should not have any big problem with that. You have to be sure that you have authentication when people access the data. You have to be sure that you have redundancy, robustness, all that kind of stuff. It's already exists. So if we want to deal with our data properly, we have to look into internet industry and just do the same, and normally it's fine.
Yeah, this is the answer for the first part regarding the autonomy of the satellites. I have studied about a nano satellite on which you can port a patch which will be giving a schedule for it for maybe 7 days or 10 days, and you can update it every time whenever you require a particular image to be taken. Or so it's a similar concept. Okay, when we are uploading that patch, for that we need an extraction, like what type of data we need, and we need a scientist support that what type of data is required to be gathered from that. And that patch can be uploaded, and there are processors on board which will be processing the data, and they'll be commanding the cameras and optical sensors and all to give the required data. So there are some sort of autonomies there, but yeah, it has to become in a big way for the bigger satellites. So a limited type of autonomy is there. Thank you.
All right. Thank you, Team Big Data. And thank you to all of our 3 team projects today. An amazing morning. So give yourselves one final round of applause. I'd like to thank our jury, Mr. Steve Brody, Professor Pini Gerfel, David Mishna, Tom Kremen, So, this brings us to the end of the academic program of SSP16. It is, okay, but before you get too excited, we are going to ask you to be back here at 2:30 for a feedback session based on everything that you've gone through over the last 8 weeks. We want to hear your feedback. So if I could ask you to be back here at 2:30. Once again, thank you guys for an amazing journey through these 3 team projects. Thank you all.